All right, moving on. For this one right now, we're working on the separate handout. We're going to do number 1, and now we're adding parentheses in, so that means you're going to have a horizontal shift. All the shapes are going to stay the same. For sine, we start the equilibrium, and then we go up to the max or down to the min. In this case, this is a positive sine. So since it's a positive sine, I'll put a little plus, then we're going to go up to the max. Now this plus right here, what that means is the normal sine curve, you're going to shift it to the left. So let's go through everything. The amplitude, there's nothing written on the outside, so that's 1. So what that means is your max is 1, equilibrium 0, -1 is your minimum. So I'll leave this here. These are the y values. I'll put y there. The period is 2 pi over b. B in this case, since it's just x, it's 2 pi over 1, which is just 2 pi. Now it's going to be different. We're not going to start at x equals 0. We're going to shift this to the left. So we're going to start at x equals a negative value. And what you can do to find out where you start, take what's in parentheses. In this case, it's x plus pi over 2. And you want to set it equal to 0. Because that's what you normally start at on the unit circle, at 0 degrees or 0 radians. So then if you subtract pi over 2 to both sides, you're going to start at x equals negative pi over 2. That's going to be our first x value. Okay, the end, I'm going to take the same thing, take what's in parentheses, x plus pi over 2. Now I'm going to set it equal to what we normally end with. We normally end with 2 pi on the unit circle. And then if we subtract pi over 2 from both sides, if I subtract pi over 2 from that, that's going to give me 3 pi over 2. So the first x value is going to be negative pi over 2. The last x value is going to be 3 pi over 2. Now, how do we get all the x values in between? Well, that's where we have to use increments. So increments, again, is the period divided by 4. So 2 pi divided by 4, that reduces to pi over 2. All right, so since it's pi over 2, we're going to use that to get the x values that are in between these two. Okay, and again, you'll see how you'll check the work as you go. So if you always follow this setup, you're really you'll be fine getting the graph. Now, key points, the first x value is not 0, it's this right here. It's negative pi over 2. Okay. Then the next one, well, I'm going to add the increments to it. So if I add pi over 2 to negative pi over 2, I get 0. If I add half a pi to that, I get pi over 2. If I add half a pi to that pi over 2, I get 1 pi. And then if I add a half a pi to that, I'm going to get 1.5 pi, which turns out being 3 pi over 2. And that's good. It matches up with where I should end. So I know I'm good. Really, you'll see the toughest part is just getting the x values for all the key points. The y values should be real easy. I already wrote out the y values, which is this right here. So sine, as I said, we always start with the equilibrium. So this is going to be 0. Since this is a positive in front of the sine, we go up to the max of 1, come back down to the equilibrium of 0, go down to the minimum of -1, then go back up to where we started at the equilibrium. So then let's just take that, let's graph it. Okay, so let's move this down a little bit. Okay, let's label the axes. Let's say this is negative pi over 2, 0. This will be pi over 2. Okay, spacing everything out evenly, we'll say this is pi, and then this last one's 3 pi over 2. So we get negative pi over 2, 0. We got 0, 1. Pi over 2, 0. Pi, we're down at -1, which is right here. 3 pi over 2, we are at 0. Okay, so you see, when you connect it, it's the same shape. We go equilibrium to max, equilibrium to minimum, back to the max. Okay, so that's kind of a first example of a shift. Since it was a plus on the inside, we shifted it to the left.